All right, so we're going to go ahead and go over some examples of using these properties of the trig functions. So first we're going to start with the periodic properties. So I really want to draw your connection to these periodic properties, also to the concept of coterminal angles. So this is something that we've already talked about quite a bit. Um, and these things are very, very similar. In fact, for our functions that have a period of 2 pi, it's exactly the same concept. It's going to be a little different from tangent, but that's fine. So if we want to evaluate cosecant of 450, the way that we can think about this is, well, cosecant has a period of 2 pi or 360 degrees. So we can kind of almost ignore any full rotations that are part of this and just figure out an angle that's essentially coterminal with 450 degrees. So this is the same thing as something plus 360, right? There's one rotation plus a little bit more here. And kind of doing the math here, we can figure out that this is equivalent to a 90-degree angle plus a full rotation of 360. For our purposes, we can ignore that period, that full period of 360 degrees. And so think about this instead as the cosecant of 90 degrees. At this point, we would want to go ahead and go to our unit circle. Cosecant is 1 over the y coordinate. And then so at 90 degrees, our y coordinate is 1. So 1 over the y coordinate is 1 over 1, which is equal to 1. Easy enough. And in fact, again, this is almost the same exact thing as coterminal angles. We're really talking about the same concept here. In fact, let's go ahead and look back at this. So a 450 degree is really just 360 plus 90 degrees. We end up in the same spot. The terminal side of our angle right here is the same as 90 degrees. It has the same xy coordinates associated with it, so therefore it's going to have the same trig values. All right, so let's go ahead and talk now about tangent. Now tangent has a slightly different period. We could use 2 pi as well, but it's going to be a little bit easier, a little bit different to use pi, or 180 degrees is our period for tangent. And so, okay, 19 pi over 4, we're dealing with radians, so we're going to talk about a period of pi. 19 pi over 4 is really the same thing as 4 and 3/4 pi. Let me fix that. It's 4 and 3/4 pi. Or another way to write that would be the tangent of 4 pi plus 3/4 pi. Well, 4 pi is just a multiple of our period. So multiples of our period can, for our cases, pretty much be ignored when evaluating these functions. So we can ignore 4 pi as a part of this and really just think about this as the tangent of 3 pi over 4. And there we go. We kind of did that. Now we look at our unit circle at this particular angle and see what we are working with. So bring back up our unit circle. 3 pi over 4 is right here. It's our 3 pi over 4 angle. We've got a y coordinate and an x coordinate. Tangent is y over x. So for our purposes, it's going to be root 2 over 2 divided by negative root 2 over 2. That's going to equal -1. So the tangent at that angle is -1. Again, we found how many multiples of our period were involved. We kind of ignored them for this problem. Yeah. Go back to the unit circle. The real angle 19 pi over 4 involves 4 pi, which is actually 2 rotations. So 1 rotation, 2 rotations, and then ends up there at 3 pi over 4. You can do it that way as well. It's just sometimes it's easier to just kind of take away periods of the function off there, kind of however you want to do that. All right, and now going back to some more examples. So sometimes when we are working with solving problems involving these trig functions, we need to determine what quadrant to place our problem in. And so distinguishing whether we're in quadrant 1, quadrant 2, quadrant 3, or quadrant 4 is going to be important. And so that's going to be based on, in this quadrant, do we have a positive x value, a negative x value, a positive y value, a negative y value? That's just based on our standard coordinate system. So our x values are positive on the right side of our graph, negative on the left side. Our y values are positive on the top and negative on the bottom of our graph. So in quadrant 1, we have a positive x and a positive y. In quadrant 2, we have a negative x and a positive y. In quadrant 3, we have a negative x and a negative y. And in quadrant 4, we have a positive x and a negative y. So I'm going to use these just to sort of help me figure out what quadrant I may be in, given the definitions that I'm dealing with. All right, so for problem number 1, we have a cosine value that is greater than 0. So cosine is positive. That's what greater than 0 means. Cosine is the x-coordinate, so we're just saying that x is positive, x is greater than 0. So that's going to place us in either quadrant 1 or quadrant 4. That's where we have a positive x-coordinate, so 1 or 4. We're going to have to use that second piece of information to help us sort of narrow that down a little bit. So the next one is saying that the tangent of our angle is going to be greater than 0, so our tangent is going to be positive. Remember that tangent is y over x. So in order for y over x to be positive, already knowing that x is in fact positive, if y was negative, this would not be true anymore. This would be a negative value. It's not greater than 0. So our y value does also have to be positive. So that kind of eliminates quadrant 4 from our options, because quadrant 4 would have a negative y value. We'd end up with negative y over positive x, which is a negative. Not going to work. So for this one, it is quadrant 1. That is the only option to place this particular problem in. All right, next question, looking at number 2. Same process I'm going to follow here. In this one, we have the cosecant is negative, is less than 1. So cosecant is negative. So that means that 1 over y is negative. That's only going to be true if y is negative. So if y is negative, that's going to put us in either quadrant 3 or quadrant 4. That's where our y coordinates are negative. The next part here, this saying is the cosine of our angle is greater than 0. So our x coordinate is positive. It's greater than 0. X is positive in quadrant 4. So y is negative, x is positive. This has to be quadrant 4. That's the only place we could actually place this problem. And then our last one, kind of going through it again, cotangent is less than 0. So cotangent is x over y. That one's got to be negative. I'm going to talk about that one in a second. So this one here is a little bit more straightforward. Sine is greater than 0. So y is positive. So y is positive is going to place us in quadrant 2 or quadrant 1. That's where our y coordinate is positive. Now between those, I need to figure out which one is going to have a negative cotangent value. Well, if y is positive, the only way this is going to be negative is if x is negative. If x is negative, that's quadrant 2. That's going to give us a negative divided by positive. So this one has to be in quadrant 2. So this is kind of like a beginning step to solving a lot of trig problems. We'll need to place the angle in the proper quadrant so that we can get the right positive or negative values associated with our trig functions. If we put it in the wrong quadrant, we're gonna be close on a lot of our answers, but they'll differ by a positive or negative if we end up in the wrong quadrant. So we'll need to be kind of careful about figuring out which of the quadrants do we draw our problem in to kind of make sure we're accurate with our solutions. All right, so next we have, all right, so starting with sine and cosine, we're going to find out the remaining 4 trig values. So to do this, I'm going to be using my reciprocal identities and my quotient identities. I could draw an angle out and kind of figure out where I'm at, but I'm just going to use the identities that were given to us. So sine and cosecant are reciprocals. So using the sine ratio, I can easily figure out that cosecant is the reciprocal of sine. So instead of negative 1/3, it's going to be negative 3 over 1. which is -3. Easy, right? And then the next one, I can figure out secant based on cosine. Secant is the reciprocal of cosine, so secant of the angle is going to be the reciprocal of this, which is actually a little messy, but that's fine. Writing out this reciprocal, I do need to rationalize it. I need to multiply by √2 on the bottom and top. So my numerator becomes 3 √2, and my denominator becomes 2 times 2, which is 4. Right? This is √2 times √2 is 2. Multiply that by 2, I get 4. So that's my secant value. So now I've used my reciprocal identities to figure out cosecant and secant. The next thing I'm going to do is use my quotient identity to figure out tangent. So my quotient identity is that tangent is equal to the sine of the angle divided by the cosine of the angle. So I'll write that out. Sine divided by cosine. Instead of dividing these fractions, I'll multiply by this reciprocal. So I'll do -1/3 times 3 over 2 √2. These 3's will nicely cancel, but we're still going to end up with something that needs to be rationalized. Again, I need to multiply by the square root of 2 on the bottom and top. It's going to give me 4 again on the bottom in the denominator and just -√2 on the top. So that is my tangent value. And I could go ahead and use the other quotient identity if I want and figure out cotangent. Another thing that I can do is I can use my other reciprocal identity. Since I know tangent and cotangent are reciprocals, I could sort of pick any of these stages here and just flip it over into its reciprocal. That actually seems like the easiest way. And if I'm strategic about it, I can pick one that's really nice. If I flip this first one over into its reciprocal, well, I still got to do a bunch of multiplying fractions, so maybe that's not the best. And if I flip this last one into its reciprocal, I'll have to rationalize it, so maybe not that one. But if I take this stage right here, and I turn this one into its reciprocal, well, that I won't have to rationalize, so that's the one I'm going to do. Cotangent of my angle is going to equal 2 √2 over -1, which is just -2 √2. So again, I'm just sort of using a mixture of my reciprocal identities and my quotient identities to use sine and cosine to define the other trig ratios. So like sine and cosecant being reciprocals, cosine and secant being reciprocals, using sine and cosine with my quotient identity to define tangent, so on. A lot of practice in here. Because these have radicals and they're all involving fractions, this process can be a little complicated with all the rationalizing and stuff. But I'm using those identities to answer these questions. All right. We'll move on to another example of this real quick. So again, we're starting with sine and cosine. The easy start is again the reciprocal. So sine and cosecant are reciprocals. So just take this and flip it. So I get -√5. Same here. Take this and flip it for secant. So it's going to be -√5 over 2. So now we're already at 4 out of the 5. Or yeah, we have 4 out of the 6. So we need to figure out tangent and cotangent. I'm going to go ahead and do tangent first, just because I feel like it. Tangent is sine over cosine. That's again using my quotient identity. So that's -1 over √5 over -2 over square root 5. Again, change that to multiplication times square root 5 over 2. These cancel out. We have negative times negative, which is a positive. We have 1/2. That one actually simplified nicely. And then cotangent is the reciprocal of tangent, so 2. And there we go. This one was a little easier than the last one. I also skipped over a little bit of the details as I was simplifying some of these things, but It's not too bad. Again, I'm using a mixture of my reciprocal identities, which ones are reciprocals, flip those fractions around, and then my quotient identity to get tangent here initially. All right. Next step here is a little more complicated. We're gonna involve that sort of finding the quadrant process that we were dealing with before into what we were just doing with like the identities and stuff. So here we know the cosine of a particular angle, and we also know that the angle is in between 270 degrees and 360 degrees. Okay, so we're dealing with degrees. This would be 0 degrees. This would be 90 degrees. This would be 180 degrees. This would be 270 degrees. And then a full rotation, this would be 360. So we're dealing with an angle that falls between here. So we're dealing with an angle in quadrant 4, right? And that makes sense. Okay, if the cosine is positive, the x value is positive, that does actually work here. So I'm going to go ahead and sketch in an angle in there. And here's my angle with my initial side and terminal side. And I don't really know what the angle is. It might be a positive angle rotating like this way. It might involve multiple rotations, might be a negative angle. Doesn't really matter. It terminates here. It's going to give us the same point. For our case, we're going to assume we're on the unit circle because I'm going to be using my cosine value. So my radius here is 1. And if I draw in my perpendicular to draw it up there, I know the x value is right up here, is my cosine. It's 3/5. And the only thing that I'm missing is the y value. I don't know what y is equal to. Well, this is a right triangle. I can figure that out using the Pythagorean theorem, right? The x squared plus the y squared equals 1. Or it's also the same thing as my, what's it called? The Pythagorean identity. Cosine squared plus sine squared equals 1. Anyway, I'm going to go ahead and do that. So I get 3/5 squared plus y squared equals 1 squared. Remember with the Pythagorean theorem, the hypotenuse always got to be the c, always the radius in these cases. So we end up with 9/25 plus y squared equals 1. I'm going to go ahead and make these be common denominators. So 1 can be written as 25/25. Again, just to have common denominators for this process. Then I'm going to subtract 9/25 from both sides. I get y squared equals 16/25. And then I need to take the square root to finish this off. And the square root of 16/25 is going to be 4/5. So I figured out that y is 4/5. And remember, y is our sine value. I'm going to go ahead and delete this stuff. The only thing I need is that y was 4/5. That is my sine value. So sine of this angle is equal to the y coordinate 4/5. All right. From here, this process is just like the one that we just did. We know sine and cosine now, so we can use our reciprocal identities, quotient identities, and everything else to find the remaining 4. I'm going to kind of go through it the same way. All right, so, so in this case, cosine is reciprocal of secant. So 3/5 becomes 5/3. Sine is the reciprocal of cosecant. So 4/5 becomes 5/4. And then we got to get a little more technical. We're using the quotient properties now, quotient identities. Tangent is sine over cosine, which is 4/5 divided by 3/5, or multiplied by 5/3. So we end up with 4/3 for tangent, and then cotangent is just reciprocal of tangent, so that's going to be 3/4. As I go through this whole process, I realize I have actually made one mistake in this whole deal. It's working with my negatives. So because we're in quadrant 4 here, the y coordinate would be negative. So this is a negative value. That means that cosecant is also going to be negative, because when I flip that, that'll be negative. That means that I need to put a negative here when I did this process, which makes tangent negative. And then if tangent is negative, when I use my reciprocal property, cotangent will also be negative. So kind of a small error there, but definitely did affect my answers. I didn't pay attention to which quadrant I'm in. So that's an important aspect. You do want to make sure you're paying attention to which quadrant you're in and whether that makes the x or y positive or negative. And that's going to have an effect on these different ratios. Like I got the right numbers, they just were the wrong signs for a majority of them actually. Here. Okay, so those are our answers and moving forward. All right, and here's my last example. So same idea, I first need to figure out what quadrant I'm dealing with. I have a cosine value of -1/4, so that means my x is negative. So I'm either in quadrant 3 or quadrant 2 over here. That's where I have negative x coordinates. And then my tangent is positive, so that means that y over x is positive. If I know that x is negative, the only way this whole fraction is going to be negative is if y is negative. Because that's going to give me a negative divided by a negative is positive. So the only place where I have both negatives, x and y, is quadrant 3. So our problem is going to be in quadrant 3 here. So I'm going to get and sketch an angle in quadrant 3. And I'm going to drop a perpendicular down to the, or up to the x-axis to give me our right triangle. We know the cosine is -1/4. Again, I'm not scaling this anyway. I just drew a generic angle in quadrant 3. Again, I don't know why this time, but again, remember, I didn't do this last time, but y will be a negative when I solve for it because we're going down here. And then our radius is 1. So just go ahead and go quickly through this. It's -1/4 squared plus y squared equals 1 squared. That's going to be 1 over 16 plus y squared equals 1, which is 16 over 16. And then subtract 1/16. Going a little fast here, but it's just the Pythagorean theorem. We get y squared equals 15 over 16. When I take the square root of that, I get square root 15 over 4. And so that's going to be my y value. So I'm going to take that and move it over here. Right here. And remember, y is negative in this spot. So y is negative in this spot. And I'm going to go ahead and delete the rest of this because I don't need to keep that. Okay, so my y value is negative, and we're going to put it right here. There we go. All right, so from there, that's my sine value. That doesn't reduce, unfortunately. It's a little messy, but that's my sine value. Is negative root 15 over 4. And then from here, we can get all the rest, right? So cosine is reciprocal of secant. So secant of our angle is going to equal -4. Cosecant is going to be the reciprocal of that, which is going to be -4 over root 15, which really should be rationalized, but doesn't rationalize particularly nicely. That's going to be -4 root 15 over 15. So that's a pretty messy little fraction, but oh well. And then tangent, let's go with tangent. Tangent is y over x, so that's going to be negative root 15 over 4 over -1/4. So again, that's multiplying by the reciprocal there. The 4's cancel, negative times negative is positive. I actually end up with just root 15 for tangent. And then cotangent is the reciprocal of root 15, so that's 1 over root 15, which when rationalized is going to be the square root of 15 over 15. So that's for cotangent value. Again, it's kind of as messy as the numbers are because we had a little bit of a messy value there. We had root 15s involved and had to do some rationalizing, but I was just applying my reciprocal relationships, my quotient relationships once I figured out sine and cosine. And that's it. We're not going to do any of the others. We're not going to talk about applying the Pythagorean identities and extensively, or the even odd properties. Those are going to be some pretty basic ones. You can find those in the homework if you want to look at those. So make sure you're doing your 2.3 homework, and I'll see you guys in class next week. All right.